All right, so our learning targets for today, we'll be able to find the sum, difference, and product of the binomial expressions. Now, if you noticed something when you wrote these down and changed the problems, did you notice you were basically writing the same two binomials over and over again? That 2x minus 5 and the 3x minus 4? Now, does that mean we're going to get the same answer every single time because we're using the same two binomials? Not really, all right? Not quite. So, if we're going to find the sum, we're going to have to add, right? We're going to have to do addition. But what are we really thinking about with distributing? Because I got to try to break down these parentheses. We're distributing a positive 1, okay? And so to think about this, those parentheses aren't really important to us because 2x minus 5 can't be done. 3x minus 4 can't be done. So if you think about trying to undo them, we're kind of like distributing a positive 1, which positive times positive is positive, and positive times negative is negative, so nothing's going to change here. So I can just rewrite this as 2x minus 5 plus 3x minus 4. So adding doesn't really change any of the signs. So that's important to remember. And the reason why we can just rewrite it without the parentheses is nothing in there was alike, and the associative property allows me to add in parentheses and then also take them away. So now I have 2x minus 5 plus 3x minus 4. Now I need to combine like terms. So I like to put the terms that are like next to each other, and the ones with variables, they go out in front. So we're going to have the 2x and the 3x out first, and then the negative 5 and the negative 4. So make sure you always include the sign in front. All right. So 2x plus 3x, remember we're going to add this number here, but we're not going to change this exponent. And I don't even want to bring this up, but 1x and 1x stays just 1x when we're adding these. And then a negative 5 and a negative 4 make negative 9. So our answer ends up as a binomial. And there you have it. First one's in the books, 3 to go. Any questions, please type them in the chat and let me know, or just use your microphone. Question number 2 is subtraction. So I would like you to subtract. Now they're the same two binomials, 2x minus 5 and 3x minus 4. But what's different? We're going to distribute a negative 1. All right? So that's going to look like this. It's going to have a negative 1 here, and we always distribute this way. So when we multiply, that's going to make a negative 3x. A negative times a positive. And when we multiply again, a negative times a negative, that's going to make a positive 4. So we have negative 3x plus 4. Now that first binomial, again, you cannot subtract those terms. They're not alike, 2x minus 5. So we can just break them out of the parentheses, the old get out of jail free card. Once we get there, combine your like terms. Terms that have the same variable and same exponent are alike. So 2x minus 3x go together. Negative 5, positive 4, always keeping the sign in front. Go ahead, combine your like terms. A positive 2 and a negative 3 make a negative 1x. And a negative 5 and a positive 4 would be a negative 1. So again, a different answer than what we just saw when we added these. Still a binomial. Still like your bicycle with 2 wheels. To an example in which we have the same two binomials, but only one of them's in parentheses. And so this comes up, and I just wanted to show you how it's a little bit different than when we have parentheses around both. So we're going to simplify the expression. We're going to need to distribute. What are we going to need to distribute? A negative 5. Okay? So because there is a negative 5 out in front of this, we're going to have to follow order of operations. So we're going to have to do this first. So that's going to create a negative 15x because we have to distribute the negative, not just the 5, and then again to the negative 4 for a negative times the negative, which makes a positive 20. Now that 2x that we did not use yet does get brought down, and so it ends up being 2x minus 15x plus 20. So the distributing looked a little bit different there, and I just wanted to bring that to your attention because you got to do that first. Quite often we see students doing something else first, which I don't want to mention because I don't want to create bad habits, get you thinking that, but just remember, distribute before any other operation here. Now let's combine like terms. No reason to change the order. It's in the order we want with the variables up front, but we do have a positive 2 with a negative 15. So if I owed somebody $15, needed to pay them, I had $2 to give them, I'd still owe them $13, and then plus 20, ending with a binomial. All right, again, just like your bicycle, just like your bifocals, those have 2. All right. We're going to finish it up here with the grand finale, the thing that we talked about last time, and that is multiplying binomials. All right. So in example number 4, let's find the product. Now we have 2 different ways to do this. We could use the distributive property, or we could use the box, and I will do it both ways. I am going to start with the distributive property. So to distribute this, I actually have to break up the first one into 2 parts. It's a binomial, right? 2 pieces. So we're going to distribute the 2x and the negative 5 to 3x minus 4. 2x times 3x minus 4, and then again negative 5 times 3x minus 4. So I broke the first piece up into 2 parts so that I could multiply it by the second binomial. I use that same thing twice. After that, it's your same exponent and distribution rules. So 2x times 3x, well, 2 times 3, 6, x times x, x squared. And then 2x times negative 4, negative 8x. From there, we go ahead and we distribute the negative 5. So multiplying again, this time just the negative 5, negative 15x, and negative times a negative, positive 20. So it looks like we have 4 terms, but we really don't because these terms are alike. So again, when like terms can be added or subtracted, go ahead and do so. Positive 6x squared goes out in front. A negative 8 with a negative 15, same sign sum, meaning we add them up. It stays negative because we are adding. If you owed $8 and you owe $15, well then you owe $23, and then you finish it off with plus 20. Okay? But basically what you do is you break it up into 2 parts. So the 2x goes over this column, so these 2 boxes, and then the negative 5 goes over this column, those 2 boxes. I changed my color so I can't, confuse it with what else is going on here. And then we've got the 3x for this row, so these 2 boxes on the left and the right, and then the negative 4. Okay? And then it's just as easy as multiplying to kind of line up the squares. So you want to try to multiply to fill in that spot. So maybe a multiplication symbol here to remember that, but 2 times 3 is 6, and 1x plus 1x makes 2x's. You're bringing those 2 x's together, and the only way to show that, since there's a number already in front of it, is to put it over the top, so x squared. And then we got the 3x and negative 5, so negative 15x would go here, so the 3x matches with the negative 5. The 2x and the negative 4, negative 8x. And finally, the negative 4, negative 5, negative times a negative, positive 20. Try to find the like terms before you rewrite this. Not a bad idea to kind of look inside and see, hey, these are the same. Typically, that's where they do end up being alike. So now let's rewrite this as largest exponent first. And again, it's going to be a very similar answer, if not even the same, if I do this right. Negative times a negative, negative 23x, positive 20. So I put this in descending order by exponent. X squared, x to the first, and then no variable at all. We finish this up in a trinomial form because there are 3 terms that are different. X squared, different than x, different than a number with no variable. All right?